Radio question 2 for the VCAA 2020 chemistry exam, and it looks like we've got a electrolysis cell here. We've got power going into two electrodes, and let's have a look what's happening here. The electrolysis of carbon dioxide in water is one way of making ethanol. I did not know that. The diagram below shows a CO2H2O electrolysis cell. The electrolyte used in this electrolysis cell is sodium bicarbonate solution. That sounds pretty cool. Alrighty, anyway, we're using a zinc copper electrode, which is fancy. And we've got some half equations here, which is awesome, so we can work with that. Identify this as the anode or cathode in the box on here. So therefore we've got anode or cathode here. What tells us that is the fact that we've got the negative charge here. This is negative, this is electrolysis, so we're electrocuting a cat. So therefore this is the cathode. Because in electrolysis, the cathode is negative. So we're looking for anything that would identify our cathode there. Determine the applied voltage required for this electrolysis cell to operate. Applied voltage is what we need to work out is something larger than the difference between these two here. So therefore the difference between these two here is clearly 0.73. So therefore anything greater than 0.73 volts will give us our electrolysis cell. We need to overcome the actual potential difference in these half cells. That's the important thing. We need to get a larger voltage than these things would produce if they just reacted spontaneously together. We need to drive electrons in that direction. Write a balanced equation for the overall electrolysis reaction for here. So what's happening here is we're doing electrolysis. So therefore this guy is going to be going forwards and this guy's going to be going backwards. So therefore, let's just work out what's going to happen here. We also need to multiply this guy by 3 because we need to have the same number of electrons on both sides of our reaction. So therefore times that by 3 and then we're going to add them together. So what that means is we're going to start off with CO2 or 2 of them, adding on 9 waters, so plus 9 waters. Our electrons will cancel out, and then we're going to also react this here, which is going to be 12OH negative aqueous. Actually, I'll deal with the states later on. And then these are going to form our products, which will be our ethanol, C2H5OH, our 12 hydroxides, which I can see are going to cancel out nicely, which is great. I'll deal with that afterwards as well. Adding on our products of this reaction here, so therefore 3 times water will be 6H2O, or not, and 3 oxygens because it's 3 times oxygen there. Now, as I said, I'm going to need to cancel down, so therefore the hydroxides are going to cancel out nicely, and my waters are going to cancel down, so I'm going to cancel out all those. That's going to come down to just 3. So let's write it neatly, is 2 CO2, and that's going to be a gas, plus 3 waters, that is going to be liquid, that is going to react and form my ethanol, which is going to be a liquid, and it's going to then also have 3 oxygens, which are going to be gases. Now that's a relatively painful addition of these 2 equations, but doing it systematically and then clearly seeing what's happening is really important there. Knowing the fact that we need to multiply this guy by 3 to get our electrons the same, and then knowing that we have to cancel down and put states in. But systematically, it's fine to do that type of question. Let's move on. Identify the oxidizing agent in the electrolysis reaction and give your reasoning using oxidation numbers. So the oxidizing agent is the oxidant, and that is reduced. So the wording for these type of redox stuff is annoying, but oxidizing agent means it causes oxidation to happen and itself is reduced. So what's happening here is what is being reduced. Where's my reduction occurring? It's this reaction here, so therefore I should expect my carbon dioxide to be the oxidizing agent. Let's just double check that with, what are they called? Oxidation numbers. So this guy here in CO2, we've got -2, -4, so carbon here is +4. And let's have a look what carbon is over here. in C2H5OH. That's -2, that's +6. So therefore, each of these, for this to be right, they have to be +2. So therefore, each one, is that right? Hang on, -2 for oxygen, +6, so therefore overall it's +4, so that has to be +4. So each carbon here is +2. So therefore, oh, you can't really see that. What I did is I worked out my oxygen here is -2. All my hydrogens together are +6. That makes overall +4. So therefore, my carbon here has to be -4 actually. So therefore, each one will be -2. Just you're working out oxidation numbers of these guys. So I can say that my oxidizing agent will be CO2, and because carbon's oxidation number has gone from, what was it? In carbon dioxide, it was +4, down to -2 in ethanol, down to -2. So a reduction in oxidation number says the fact that this is our oxidizing agent because it has been reduced. Reduction in oxidation number means the stuff has undergone reduction. And we know that as well. We can see it. It's gone on reduction because it has gained these electrons as well. So lots of different ways you can actually approach that, but you definitely need to then bring it down to talking about oxidation numbers. So let's move on. Anyway, a current of 2.7 amps has passed through this electrolysis cell. The cell has an efficiency of 58%. Time taken, we need time taken for this cell to consume that many mole of carbon dioxide. Alrighty, so what have we got? We've got, what are my equations? Q equals IT, I know that much. So therefore this is going to give us our time. So therefore Q also equals number of moles of electrons times by Faraday. So any calculation equation, calculation question, I'm first of all defining my my relationships. So therefore Q equals IT, Q equals N times that. So therefore if I've got, therefore I need to find my number of moles of electrons. Number of moles of electrons, what is the ratio between electrons and carbon dioxide? Number of moles of electrons to carbon dioxide is 2 to 12. So therefore, if I look at that, it's 1 to 6. So therefore, I can say that equals 6 times my number of moles of CO2. So therefore, let's just get my trusty calculator out and I'll clear what I've got there. 6.05 times 10 to the power of -3. Yep, that's fine. Times that by 6 gives me 0.0363 mole of electrons. So therefore I can find my Q now. So therefore number of moles of 0.0363 times 96500 times that by 96500 gives me 3502.95 coulombs of charge. I can whack that over here to say that T equals Q over I. So therefore I can take this, which is 3502.95, divide that by my amps, which is here, 2.7, equals my time in seconds. So take that number, divide that by 2.7, gives me 1297.39 seconds. This is clearly way too many snipping figures. My snipping figures are going to come down to being, actually I haven't taken into consideration my efficiency yet. So therefore, if it is that efficient, I'm going to end up with it taking longer to do that. So therefore it should be that divided by 0.58 to take into our efficiency. So do that divided by 0.58 gives me equals 2236.9 seconds Again, way too many significant figures. I've got 1, 2, 3 significant figures, 1, 2, 3 significant figures, 1, 2 significant figures in my percentage there. So I'm going to take this down to being 2 significant figures, which is going to be 2.2 times 10 to the power of 3 seconds. And that should be my answer, which I hope it actually is. Is that all we need to do? In minutes. Alrighty, take that, divide it by 60, gives me 37 minutes. And now that's my answer. Alrighty, 37 minutes because I needed to work out in minutes. And that is the answer to part E. And is that the rest of, that's all question 2 done.